Welcome to the deep dive. Today, we're getting into something pretty fascinating, actually. It's a piece of industrial kit, the Pedrazzoli SN300 bandsaw. We've looked at the sources, and really, our mission here is to unpack the smart design choices, the things that give it this reputation for precision and reliability, to help you understand what makes a machine truly well-engineered.
Yeah, exactly. Because look, in metal fabrication, it's a demanding world, right? Not all tools are built the same.
Yeah.
And Pedrazzoli, well, they seem to be really aiming to set new standards here for dependability, for accuracy. It's not just another saw.
Okay, so let's start with maybe the most obvious thing from the sources, this emphasis on stability. They talk a lot about the heavy-duty cast iron bases.
Yeah.
What's the real story there? I mean, beyond just, it's heavy.
Well, yeah, it is heavy, but the fascinating part isn't just the mass itself. It's about tackling this kind of invisible enemy, microvibrations. You see, lots of saws might look stable, but tiny movements during the cut, they can mess with the squareness, the finish, and they even wear out your blades faster. So this big cast iron base, it basically acts like a giant damper, soaking all that up.
Ah, okay, so it's foundational.
Absolutely. It's like the silent guardian for, keeping that blade sharp longer and making sure every cut is just spot on.
Right. So once you have that solid base, what about flexibility? I noticed the saw head positioning pretty wide range, 60 degrees left, 45 right, and the vise shoulders adjust too. How does that system really let an operator handle, like, all sorts of different jobs without losing that precision?
That's where the design gets really clever. That movement, it happens on a large circular miter base, right?
Mm-hmm.
But it rotates over a tempered bearing track. Think of that track as like this super hardened, perfectly smooth pathway. It lets the whole saw head pivot with almost zero play or friction.
So the angle you set is the angle you get every time.
Precisely. Yeah. And then you add those vise shoulders that can retract and adjust. It means the machine cups to the workpiece. Whether you're cutting, I don't know, thin tubing or a chunky I-beam, you get consistent, solid support. It's built for adaptive precision.
Okay, moving on to the actual cutting. The sources mention gravity-controlled downfeed and a dynamic feed mode. What does that actually mean for, the person using it? How does it help?
So you've basically got two main ways to operate it. There's a manual mode, right, where you, the operator, directly control the down pressure. Good for tricky stuff. But the dynamic mode, that's where it gets interesting. Gravity handles the bow's descent. It sort of lets the blade pressure adjust almost intuitively based on how tough the material is, like a skilled person would do by feel.
Huh. So it adapts the feed rate.
Yeah, in a way. And then there's a limit switch, so when the cut's done, the blade just stops automatically, frees up the operator. It's really about getting that consistent cut, avoiding binding, especially if the material isn't perfectly uniform.
Gotcha. And then there are these under-the-hood details, the vertically mounted motor and the oil bath for the worm gear drive. Sounds technical, but what's the practical benefit there?
Right, those might seem like small things, but they have a big impact. The vertical motor, that just makes the whole machine more compact. Saves floor space, which is often tight. And the full oil bath for that worm gear drive, which, by the way, is a great design for torque and holding position, everything inside is constantly lubricated, constantly cooled.
Less wear and tear then.
Way less.
Yeah.
It means longer life for those core components, less maintenance downtime. It's engineered for the long haul, for demanding work, saving you time and hassle.
And you can't talk industrial machinery without talking safety. The sources mention things like the safety switch and the hand grip, the micro switch on the guard.
Absolutely crucial. And the key is they're integrated, not just tacked on. They're part of the machine's basic design philosophy, making sure that efficiency and precision don't compromise safety, builds operator confidence.
Yeah, makes sense.
So yeah, fundamentally, the Pedrazzoli SN300. It's not just a list of specs, it really is a testament to integrated design. Every single piece, from that heavy base dampening vibration to the clever feed modes, the robust drive, it all works together for that reliability and precision they talk about.
It really does highlight how much thought goes into a truly well-engineered tool, which kind of brings up a bigger question, doesn't it? When you look at any technology you use, maybe in your workshop, maybe somewhere else entirely, how much does that unseen engineering, the stuff under the surface, like in this SN300, really shape your experience, what you can actually do with it? Makes you wonder, what else might you uncover if you took that deeper look at the why behind the what? Something to think about.